Welcome back to GATE AIML. So today we'll solve few more previous year questions from GATE. Okay, so let us start. Consider the following experiment. Step 1, flip a coin twice. Step 2, if the outcomes are tails heads, then output Y and stop. If the outcomes are either heads heads or heads tails, then output N and stop. Step 4, if outcomes are tails tails, then go to step 1. The probability that the output of the experiment is Y is dash. Okay, so let us say step 1, what they are saying in step 1, flip a pair coin twice. Okay, so what will be the outcome? Let us write the sample space. If I flip a pair coin twice, it can be head head, head tail, tail head, or tail tail. Now second step, if the outcomes are tail and head, the outcome is tail head, then output Y and then stop. Next, step 3, if the outcomes are either head head or head tail, then output N and then stop. Step 4, if the outcomes are tail tail, then go to step 1, is what they are saying. Okay, now the probability that the output of the experiment is Y. The probability that the experiment is Y. See, it's not a straightforward question, because if you have stopped at this point, then it is fine. You can directly calculate it as the possibilities. But it is in a loop. If I go to this step, this happens, TT happens, that is tail and tail in both the thoughts. Then I have to again conduct the experiment, repeat the experiment. So now let us see how to solve this. Okay, the first step is, what is the probability of Y? Find the probability of Y. What is the probability of Y? Probability of Y is TH. So how many? So TH out of 4 outcomes. So probability of Y is, getting Y is 1 by 4, right? Out of these 4 outcomes, getting TH is 1 by 4. Then probability of, say, N, the second case, the third step. So 2 out of 4, HH or HT, that is 2 outcomes out of 4 outcomes, that is 1 by 2. Then last step, probability of, let us say, repeat, R, represented by R. So it is what? Again TT, that is 1 by 4. Okay. Now how will you solve this next? See, what is that? I have to get TH. Till then I have to continue the experiment if I get TT. So here, when will you repeat the experiment? You will repeat the experiment if you get TT, that is 1 out of 4. How to solve this? There are many methods to solve these questions. So let us understand this in this way. See, in the first trial, say I will get, so the total probability, let us be P, of getting Y. So in the first, if I get 1 by 4, then what will happen? So I have to stop, right? So that is one chance. Next, suppose if this is not possible, that is in the second trial, I will go to second trial. When I will go to second trial, I have to get this case, right? So this case is 1 by 4. That means if this happens, I will go to second trial. And in the second trial, I can stop only if I get Y, that is again 1 by 4. Plus, even if this trial also fails, the other option is third trial. Go on doing like this. So it will be 1 by 4 into 1 by 4, because 2 trials have to fail, and then multiply by the Y. I will pass here. Like that you go on till we don't know, till we get that. That is infinity. This is nothing but sum to infinity of a geometric series or geometric progression. So in your high school you might have learned this is given as a by 1 minus r, where a is the first term, is a, and r is the common ratio between any two terms. So common ratio 1 by 4 into 1 by 4 divided by 1 by 4 is 1 by 4. So I will get 1 by 4 divided by 1 minus 1 by 4. So the outcome will be 1 by 3. This is the final answer. Next, let S be a sample space. Okay, let S be a sample space and two mutually exclusive events. Please remember this: mutually exclusive events A and B. When I say both are mutually exclusive, the probability of A intersection B is equal to what? Is 0. You already learned this concept. Then they are saying A union B is yes. This is probability of A union B is equal to the sample space itself. That is probability of sample space. See, what is the probability of sample space? The sum of all the outcomes, that is 1. Probability of sample space, that is the axiom, right? The axiom of the probability theorem. Then if P dot denotes the probability of an event, what is the maximum value of PA into PB? So how will you find PA into PB? So given that P of A union B, we know that P of A union B is equal to P of A plus P of B minus P of A intersection B. Okay. Now, so this is already given as 0. So P of A union B is equal to 1 is equal to P of A plus P of B. What is that I have to find? I have to find the maximum to maximize this PA into PB. Now, let us say PAB X, then what will be PB? It will be, to send this side, it will be 1 minus X, right? If you add these two, you will get 1. That is the meaning. So, what I am trying to say here is maximize P of A is X into 1 minus X. So, I am just putting P of A as X and P of B as 1 minus X. So, this will be maximize X minus X square. So, this is now maximization problem. How will you solve this? You have to find the maxima of this. So let us take this represented by f of x equal to x minus x square is a function. So how will you maximize it? So I need to maximize f of x. So first, to maximize you have to differentiate with respect to x. Okay. So let us say d of f of x divided by d of x, that is equal to, if I differentiate that f of x, it will be 1 minus 2x. Now check whether we will get a maxima or not. How will you check? Again, go for the second differentiation. Okay, is equal to minus 2. This is less than 0. Hence, maxima exists. Maximum point exists, right? If it is greater than 0, then it's a minimum. Okay, so this basic differentiation rules you already know. Now, what is the maximum? How will you get it? So equate this to 0. So that implies x equal to 1 by 2. Now what is f of x maximum value? This is nothing but x minus x square, right? So put that value here, 1 by 2 minus 1 by 4. So we will get 1 by 4. This is the final answer. A very beautiful question. Next, the probability that a given positive integer lying between 1 to 100 is not divisible by 2, 3 or 5 is. Okay, very simple question but very lengthy. Now, probability of divisible by A. Okay, A, so let us say A is getting divisible by 2, B is the event which is divisible by 3, C is the event which is divisible by 5. Okay, I just written equal to, but understand it. is divisible by 2, 3 or 5, A, B, C respectively. So now I will calculate P of A using inclusion exclusion principle. You can directly find it. You can just go on counting in 100 how you can do it. But simple way is, you learnt in your primary or high school mathematics, the floor function of the 100 numbers are there divided by 2. How many are there can be divided, that is 50. By this floor function, this indicates floor, this indicates seal, that means higher value. If I get 1.2, this will be converted to 2, like that. Ceiling means that floor means 1.2, this will be converted to 1. This is the meaning. Why? Because see, if it was say 50.1, what it means, 50.1 means, or 50.5, let us say 50.5 means 101, okay, but 101 is not divisible by 3, that's why I have to ignore it, that's why we're taking the floor function. Similarly, P of B is equal to floor of 100 divided by 3, this is 33. Then P of C is equal to divisible by 5, so that is 100 divided by 5, this is equal to 20. Next. So what is the plan I am doing here? I am trying to find not divisible by 2, 3, 4 means what? I will find P of A union B union C. Okay. Not means I have to take the negation of this, that is 1 minus P union P of A union B union C. This is what I am trying to find. So first let us find this. So how will you get this A union B union C? This is P of A plus P of B plus P of C minus P of A intersection B minus P of A intersection C minus P of B intersection C plus P of A intersection B intersection C. So now we go on finding the values of these values. So now P of A and C means what? Divisible by 2 and 5, that is 10, right? You can directly write it as divisible by 10. So P of A and C is what? For A and B, let us take first. A and B is 6 divisible by 6. Floor of 100 by 6. Okay, so floor of 100 by 6, you will get it as 16. Similarly, P of A intersection C is equal to floor of 100. A and C means 10. This is equal to 10. Then P of B intersection C is equal to 15. 100 divided by 15. So this comes to be 6. Okay. Now P of A intersection B intersection C is equal to all 3. So divided by what? 100 divided by 2 into 3 into 5, 30. So this comes out to be 3. Now you find out, put in these values, and then you will get, so what is the total probability value? So P of A is 50, so divided by 100, divided by 100. So you go on dividing by 100 because I am calculating the probability value here. So divided by 100, divided by 100, and divided by 100. So what you will get? So you will get 0.74. So what is that I want? 1 minus this P of A intersection B intersection C. This will be equal to 0.26. That is the answer. Okay. So it's simple only, but very lengthy. Next. 4 fair 6-sided dice are rolled. Okay. The probability that sum of the results is 22 is x by 1296. Find the value of x. They are saying there are 4 dice, D1, D2, D3, D4 are rolled. Okay. So what are the combinations? 1, 2, 3, 4, 5, 6. Here also same 1, 2, 3, 4, 5, 6. Here also 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now they are saying the sum is 22. P of S equal to 22 is already given as x by 1296. See why it is 1296? Nothing but what? 6 into these combinations, right? 6 into this, 6 into this, and then 6 into D3 values, 6, 1 into D4 values, and all those. So there is nothing but what? 6 power 4. The previous example I shown, no? If there are 2 dashes, it will be 6 power 2. 3 dashes, 6 power 3. Like that, 6 power 4 is 1296. That's they are already given. I want to find the numerator. What is the numerator? They are saying how many combinations are possible with sum 22. Okay. So you can solve it as integer solution problem, but linear integer solutions. But let us solve it simply here. The 22 is possible with all these 4 combinations. That is what they are saying. 22. So if you add the numbers, you should get 22. Exactly 22. Now don't start with 1. So if you start with 1 and 1, see, you have to get 22. 22 means should be at least big number. If you add all these 4, 4 is 16, 5 is 25. So at least from here you can start, right? You can add 5 from this, choose 5, then start with 6, 6 and 6. Is possible? No. So better what to start? You start with 1 here. 1, then if I add all these 5, it will be 10. So we'll go here now. So 1, 6 and 6. So start from here 1, 6, 6, 6, 6. So it will be 19. No, not possible. So 2, 6, 6, 6, 20. Not possible. Okay, 3, 6, 6, 6. 21 not possible. 4, 6, 6, 6, yes, it's possible. So one pair I got is, one set I got is 4, 6, 6 and 6. Okay, this path is what I'm saying. This. Next, start with 5, 5, 6, 6, 6. Is it possible? So it will be 23. It is more than 22. So it's not considered it. So now 5, 6, 6 is possible? No, not possible. So what I can do now? I have to go with a different path. Now let us go from here to here now, because all this we have tried out, it is not possible. So only this combination is possible. Now 5, 5, 10. Okay, 10 plus 6 plus 6, 12, 22. So this is possible. What is the other combination? 5, 5, 6, 6 is possible. Next 5, 5, 5, 15, 6, 20 are not possible. So any other combination here is not possible. Then go to 4. 4, check any other combination possible. 4, 4, 8, okay, 6, 6. So you check, no other combinations will be possible. Only these two are possible. These two sets are possible. See, what is that? I'm specifically saying D1, D2, D3, D4. This is, I have taken this set, but it's a permutation problem. See, it can be from D1 also, no? It can be from D4 also. This can be D4, this can be D1. Any possible combination is possible. So now you find out how many ways I can arrange this. See, I can arrange them in 4 factorial ways, because there are 4 numbers. Divided by 3 is repeated, or this combination, that is 4 factorial divided by 5 is repeated 2 times 2 factorial, 6 is repeated 2 times 2 factorial. So this value comes out to be what? 4 plus 4 into 3 divided by 2, 6. So the answer is 10. So the x value is 10. This is how you have to solve. Next, suppose a pair 6-sided dice is rolled once. If the value on the dice is 1, 2, 3, the die is rolled a second time. If the value is 4, 5, 6, it is not rolled again. What is the probability that the sum total of values that turn up is at least 6? At least 6, okay, not exactly 6. Now what they are saying, so let us say this is the first, they will start with the dice. So they will toss it for the first time, okay, first trial. So it can be 1, 2, 3, 4, 5, 6. Okay. Now if it is 4, 5, 6, it is not rolled again. Okay. So this is, it will be stopped here itself. Now if it is 1, 2 or 3, it will be rolled again for a second time. Now if it is 1, I have to roll again its first second time. So it will have 1, 2, 3, so like that till 6 possibilities. Here also from, I will not write all, 1 to all 6. Here also same, 1 to all 6. Okay, then we'll stop the experiment here. Now what is the probability that sum of total values that turn up is at least 6? Okay, first find out the denominator. How many total outcomes are there? See, 3, 1, 2, 3 into 6 times, right? 1 into this 6, 2 into this 6, and then 3 into this 6, right? So total 18, and then total this 6 are there, right? 24 combinations are possible. Outcomes, total outcomes are what? This 1 to 6, and then in the second trial 1, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, like that. 2, 1, 2. So total 18 plus 6, 24. Now how many of these will have the sum at least 6? See, for the sum to be at least 6, this is 1 there, already 6 is here. So this is 1. Next, how many will have at least 6? Starting with 1, 1 plus 1, 1 plus 2, 1 plus 3, 5. 1 plus 5 is 6, and 1 plus 6 is 7. So here 2 combinations are possible here. 2 plus 5, 2 plus 4 is 6. So 4, 5, 6 will be more than 6 or equal to 6. So there are 3 combinations. Then coming here, so 3 plus 3. So 3, 4, 3, 4, 5, 6. 4 combinations are possible. So total how many? 4 plus 2 plus 3, 5 plus 2 plus 1, 9, 20, 10 by 24, that is 5 by 12. Okay. Next, a deck of 5 cards carrying each distinct numbers. So there are 5 cards with numbers 1, 2, 1, 2, 3, 4, 5. Is shuffled thoroughly. 2 cards are then removed one at a time from the deck. Okay. So 2 cards are removed one by one. What is the probability that the 2 cards are selected with the number on the first card being higher on one higher than the number on the second side? Okay. So let us say this is card 1, this is card 2. This is chosen first, this is chosen next. Now what they are saying, this card, if it has 2, the number 2, then it should be exactly 1 more than that. That is, C1 should be equal to 1 plus, sorry, C2 should be equal to, no, I just took it other way, 1 minute. So 2 cards selected with number on the first card being 1 higher than the second number. Okay. So C1 equal to 1 plus C2. This is what they are saying. So let us choose C1, C2. Now if C1 is 1, okay, if C2 is 1, C1 has to be 2, right? 1 plus 1. If C2 is 2, this has to be 3. If this is 3, this has to be 4. If this is 5, this has to be 6. This cannot be 6 because you cannot have 7. Okay, so this is also not possible, right? Because only this is also not possible because 6 is not possible. Only 5 cards are there. So what are the combinations we have? 2, 1. So what is one more missing here? So if I can have 1, 2, 3, 4 also I can have. No, I missed it, 4. So instead of 4, it can be 5. So this is 4 ways. 4 I can have. So 4 such combinations I can have, divided by how many are there? So here first I choose 5 cards. Okay, the first card. Then I will be left with what? 4 cards, right? So total outcomes will be 20. So in 20 ways I can choose them. So this is 4 by 20 or 1 by 5. Okay. So very simple, but little bit tricky. Two fair coins are flipped. It is known that at least one of them shows head. What is the probability that both are heads? Okay. So let the sample space be 2 coins, right? Head, 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 tail, then tail, head, and then tail, tail. Now, it is known that at least one of them shows head. Okay. At least one of them shows head. What is the probability that both are heads? At least one head means what? This contains one head, this contains one head, this also one head. So there are 3 possibilities, okay, which contains head, because they want to say that at least one head should be there, and both of them are head. Probability of getting both are head is only 1. So the answer is 1 by 3. Very simple. Next, consider a company that assembles a computers. The probability of faulty assembly of any computer is P. The company therefore subjects each computer to a testing process. This testing process gives the correct result for any computer with the probability of Q. What is the probability that a computer is declared faulty? Okay, so this is again with the tree diagram, you can do it. Okay, what is the probability that the probability of faulty assembly of any computer is P. So faulty assembly, faulty assembly. The other way will be not faulty or non-faulty assembly. So faulty assembly is probability is P. Here it will be 1 minus P. Next, the company therefore subjects each computer to a testing process. The testing process gives the correct result for any computer probability Q. Next, it is subjected to testing. Okay, so the next is testing. Here, correct testing. Okay, let us represent by C with the probability Q. The testing gives a correct result with the probability Q, or incorrect result probability 1 minus Q. Okay. Similarly here, C, I C, this is Q, this is 1 minus Q. Now, what is the probability that a computer is declared faulty? Okay, how will you find this? Declared faulty means, see, this is, let me take this. Okay. First, this is faulty, okay, this path, and then Q means what? What is Q here? Q says it detects correctly, that means this path, right? So it is faulty computer, it is saying it as faulty. So this is one path I have to select, PQ. Plus, is there any other path which detects properly the test? See, if I go to this path, non-faulty, okay, this is non-faulty, but if the test is faulty, that means what? It is detecting non-faulty as faulty, right? It is detecting non-faulty as faulty. That means what? This is correct, right? That is what the meaning says, 1 minus P into 1 minus Q. This is another path. This is the answer. Next, Aishwarya studies either computer science or mathematics every day. If she studies CS on a day, then the probability that she studies mathematics next day is 0.6. If she studies maths on a day, then the probability that she studies CS the next day is 0.4. Given that Aishwarya studies computer science on Monday, what is the probability that she studies computer science on Wednesday? Okay, so let us start with, say, Monday. She starts studying Monday. So what is the subject she starts studying on Monday? She starts with computer science. This is already fixed. They are given. So from here, what about Tuesday? Okay, they already given that. See, if she studies CS on a day, the probability that she studies maths the next day is 0.6. So CS given math is 0.6 the next day. So other than maths is another subject CS. Okay, she studies CS on Tuesday is 0.4 because 1 minus 0.6. Next, you come to Wednesday. So on Wednesday, so if she studies maths, then again on Wednesday she can study math or CS. Similarly, she studies on Tuesday the computer science, then she can study maths or CS. Okay, if she study maths on Tuesday, the next day what is the probability to study maths again? That is CS is 0.4 and this will be 0.6. The probability to study CS the next day is 0.4. That is, if you study maths on Tuesday, on Wednesday she studies CS with 0.4. Otherwise, the maths is 0.6. Similarly, she studies here 6 and 0.4. Now, what is the probability that she studies computer science on Wednesday? On Wednesday, which are all the computer science branches? So she starts with CS. Okay, take the other color. Monday she starts with CS, then Tuesday CS again, CS, then Wednesday also CS. This is one path, right? 0.4 into 0.4. Next, plus, see, here also there is one CS. On Wednesday she studies. This is CS on Wednesday. So what is this path coming from? It is coming from math. So, or this is also path 0.6 into 0.4. So this comes out to be 0.4. We'll see in the next video with some more practice problem on probability theory.